Hey everyone, this is Dr. Walker. We're starting chapter 19 on electric potential and capacitors. This first video is called Electric Potential Energy. It is video 212. I'd like to start off this video by asking a question. How is this possible? A bulb glows brightly when connected to a battery, so you know that you need to connect it in order for it to glow. So why do you think that is? Are you thinking about electricity, current, light? And those are totally fine topics. But I want you to think about, how do you think potential energy, what do you think that has to do with it? So please put your thoughts in the comments below. I'd like to start off with a review of gravitational potential energy. We learned about this in Physics 1. Imagine that you are lifting a book from this location here up to this location here. So by lifting it up, you've raised it up. There's a displacement here upward. There's a force upward. So you've done work on the book. If you remember from Physics 1, work is force times distance. It can be delta x or delta y. So by doing this work on this book, you have also increased its potential energy. If you remember from Physics 1, the gravitational potential energy equals mgy. And the y here was the height relative to some reference position. So you could say y equals 0, and then you have done work on it, and now it has gained gravitational potential energy. So just to review, an object has gravitational potential energy due to its position relative to the ground or relative to some kind of reference point. So now, let's look at electric potential energy. So it's very similar. Imagine that there are some positive charges here, and that you are trying to push another positive charge from this position on the left here. You're trying to push it to the right. So in order to push it there, you're going to have to do work on it, because it doesn't naturally want to go there. If you think back to the book naturally wants to fall down. In order for it to go up, you have to do that work on it to give it that potential energy. So the same thing here. Positive charges repel each other, since like charges repel. So you have to do work to push it closer. So that means that by doing this work on this positive charge, now it has gained electric potential energy. So just to recap, a charge has electric potential energy due to its position relative to other charges. In general, if you bring positive charges closer to each other, then you are increasing the electric potential energy, because you have to do work to do that. If you are bringing negative charges closer to each other, you are also increasing their potential energy. However, if you have a positive charge and a negative charge, and you bring them closer together, then in that case, their potential energy decreases, because that's the direction that they naturally want to go. They naturally attract each other. So just a note here, a hand does not actually push a single charge. That is just for visualization purposes. The best way to think about it in my mind is just think about the book. If the book is naturally going where it wants to go, which is down, then it loses potential energy. If you have to lift it up, it gains potential energy. So think about what the charges want to do, and that will tell you if the potential energy increases or decreases. Let's look at one question. As a positive charge is moved from position I to position F, what happens to its electric potential energy? So pause the video, think about it. So let's take a look. We have a positive charge here, and it's moving to the right. Well, that's the direction that it naturally wants to go, because positive charges are repelled. So if it's going the way it wants to go, then its potential energy is decreasing. So repeat for a negative charge. What do you think is going to happen? Well, for a negative charge, if you have a positive charge here, then you have that negative charge that you're moving to the right. Then it's going opposite the way it wants to go because it naturally wants to be attracted to the positive charge. So in this case, the electric potential energy is going to increase for the negative charge. In general, as we'll see in future videos, everything tends to be opposite for negative charges. So in the next video, we will look at how the potential energy of charges change as they move from one position to another. We'll explore that a little bit further in the next video.